finally, I don't know if we'll be able to do the area rule, a problem that has the area rule today. But what does the area rule say? I've already indicated. Again, I choose a non-right angled triangle. Let's call it PQR. And I have small p, small r, and small q. The area of this triangle, PQR, is then given by a half any two sides. So let's choose PR times the sine. Note it is not the cosine this time, the sine of the included angle, and in this case it is Q. Now what directs you to use P or R? It is if both P and R are given, or we are looking for R and P is given. In other words, you are directed by the given information as to which two sides you take. So it is, if you are not given P and R, but P and Q, then you would have half PQ. But now the angle made up by P and Q is R. This would be the included angle. And you come here, and finally, you could have been given Q and R, then you have half QR sine P. By the way, convince yourself that this is correct. By doing what? By first, if you have the three sides and all the angles, determining it using P and R and the sine of Q, getting a magnitude, determine it using P and Q and the sine of R, get the value, determine it using Q and R and the sine of P, and you'll find that you get the same value every single time. That, in a nutshell, is what we mean by the sign rules. Notice that I chose a non-right angled triangle. You don't need these things. You don't need the area rule. You don't need the sine rule. You don't need the cosine rule if we are having a right angled triangle. For the sine and the cos and the tan, you use the definitions of sine, the definition of cosine, and the definition of tan. For the area, you use the fact that two of those sides are perpendicular to each other, so you use half base times height. I'm sure my time is running out now. Let's recap. Let me put back this thing, because not three-dimensional as such, but the application of the sine and the cosine give children a problem. This was given like this without the x here. And what you use is your knowledge that when two parallel lines are cut by a transversal, these axioms must be at your fingertips. When two parallel lines are cut by a transversal, A, B, C, D, E, F, G, H. Then the alternate angles are equal. Now which ones are alternate here? You have H, H and E. Notice that they form a Z. That's how you'll recognize them. And F as well as F and B. Notice that they form an F. It looks funny, but it is still Z. Alternate angles are equal. Corresponding angles are equal. You have A and B. Now, if you take it down here, here's your A, here's your B. These are corresponding angles. What do you see here? You see an F. they form an F. This side too, you have a G and an E. And if you look at this, you have an F. Yes, it's facing this way, but it is still an F. You need to be able to recognize these. And finally, although we seldom use that, you have co-interior angles are supplementary. Now, how will you recognize, apart from the F, corresponding angles? This line here is called the transversal. Corresponding angles are on the same side of the transversal. A is to the right, so is B. A and B are corresponding, they are to the right. At the same time, if this line is AB or KL, A is above KL, B is above MN. In other words, they are on the same side of their respective angles. On the same side of the transversal and on the same side of their respective angles. Similarly, when you come this way, F is to the left of the transversal, D is to the left of the transversal, F is below KL, so is MN below D below MN. So for alternate angles, they do the opposite. When one is on the right, the other one is on the left of the transversal. When one is above its line, the other one is below its line. The alternate angles. If this is to the left of the transversal, the B which alternates with it is to the right. And since this is below its line, this one is above its line. You should have these things at your fingertips so that you are able to identify which are corresponding, which are alternate, and which are co-interior. Then you won't have a problem dealing with them. If I may bring back what we started with, this angle here was not given, but we know that this is parallel to that. It forms a Z, and therefore this must be X. Remember, when you come here, we are talking about W plus X, and yet I see only W, and there's X up there. I use the fact that alternate angles, when the lines are parallel, are equal. The same thing applies to the W plus Y there. I have only W here, but there's the Y there. How do I get it here? Again, it was not even necessary for us to have used the alternate angle first. In other words, this angle is equal to that angle. We could have stopped here because there's your F. Okay? This angle corresponds with this one. So if this is Y, this must also be Y. Now I want to recapitulate by saying, when you deal with these problems, especially 3D, that require you to apply the rules, it is not only the rules that are applied, but also your knowledge of parallel lines. When two parallel lines are cut by a transversal, corresponding angles are equal, alternate angles are equal, co-interior angles are equal, which is what you have applied here. Not only that, you have also applied the fact that the sum of angles in a triangle is 180 degrees. And you also apply your cast rule. Also apply when you have theta here, let's say 30 degrees. If you move this way and you have the same theta here, 30 degrees, the sine of this, now this will be 180 minus 30, which is 150 degrees. The sine of 150 degrees is equal to the sine of 30. If we call theta, we generalize it to, say, theta, then how do we get it? It is 180 minus theta, in the same way that 150 is 180 minus theta. And I wish to reiterate that you often come across the situation where you are dealing with sine of 180 minus, say, alpha plus theta, which then is equal to the sine of alpha plus theta. But I indicated it does not mean 180 minus alpha plus theta is equal to alpha plus theta, in the same way that 30 degrees is not equal to 150 degrees. If it were live, I would take questions. Let me remove this and have this from the textbook. That this is the horizontal plane. These are vertical planes. This is a vertical plane. This is a vertical plane. And this one is an inclined plane. We're going to take a short commercial break. And when we come back, we'll continue.